Assalamu alaikum students. Today our topic is regarding addition of vectors. Now we are aware of the vector. A vector is having a magnitude. If I will represent any vector here, it is a representation of a vector. It is represented by a straight line, and that very straight line gives us the magnitude of vector. And this very arrowhead gives the direction of vector. Now we have to add vectors, but the first important condition for addition of vectors is for addition of vectors is that both vectors, or you can say 2 3 4 vectors, whatever may be the number of vectors, should have same nature. What do you mean by same nature? Same nature bole to there should be, if you have to add velocity, if this is a velocity vector, let this be velocity, this is 5 meter per second. I can add up this with only if I am having 3 meter per second, 10 meter per second, 100 meter per second, or 2 kilometer per hour, or whatsoever. I can add it because both are having the same nature, that is velocity. If this is velocity and this is velocity, then I can add them up. How I have to add, I will show that out. But first important condition is nature should be same. I cannot add velocity plus acceleration. There is no addition between two vectors of different natures. There can be multiplication, but there is no addition between two vectors of different natures. So acceleration can be added to acceleration. Velocity can be added to velocity. You have to understand it. Momentum can be added to momentum. Momentum cannot be added to velocity or force. Force can be added. Force is added to force. It is necessary condition that their nature must be same. So first we have to add collinear vectors. What are collinear vectors? You might be aware regarding the collinear vectors. So you will be having knowledge regarding the collinear vectors. If we have to add them, like we are having a vector like this, vector A, if it is a vector A, and if I have to add it to this very vector, this is vector B, as both are acting in the same direction, they are the parallel. Now I have to add the first method, which is called as head to tail method, which we are going to read here. How I can add these very collinear vectors or anticollinear vectors? By addition, what I am actually finding? I am finding a single vector which produces the same effect in the body as it produces with two vectors. That is known as the resultant vector. So let me do first, let's go step by step. This is vector A. I have to draw this vector here. I can draw it here. This is vector A up to this very mark. Is it so? Yeah, this is vector A. Now I have to drag second vector such that its tail, these are tail, this is the tail of first, this is the head of second, this is the head of first, such that its tail coincides with the head of first. This is vector B. First I draw the vector A, then I drag it to the vector B such that its tail coincides with the vector head of vector first. Then the vector drawn from the tail of first then the vector drawn from tail of first up to the head of second. So you have to see from this up to this is the same vector, gives us the resultant. So I can say R vector here equals to vector A plus vector B. What is this R vector? So R vector is the resultant of 2. It is the addition of 2. It produces the same effect as it produces by A and B. So how we can add the collinear vector? A simple method. We have to drag the first two, we are going to write vector number first, then we have to drag the vector second in such a way its tail should coincide with the head of first, but the direction has to be kept same, whatever its direction having. It was having this very direction, I have kept. I could have made it like this. That way it could have, if I would have placed B in this very direction. But that was not a right method because the direction of B I am placing like this, but the actual direction of B is like this. So I placed the B such that its tail coincide with the head of first, and it's written as like this. Then the vector drawn from the tail of first up to the head of second gives the resultant of 2, and this produces the same effect as it produced by the two vectors. If it is 5 meter per second, it's 10 meter per second, then this vector is total 10 plus 5, 15 meter per second. So it is the same vector. So this is how we are going to add the collinear. If we are having one collinear and one if we have to add these very two vectors, one vector is like this, that is B vector A, and we are having another vector like this, take the parallel direction, it's the parallel direction to this, these are parallel vectors, and this is like this, and this is opposite to it. So how I am going to make the resultant? First I will write it here as a vector A, this vector A up to this very mark. Then the rule is we have to display second vector without changing its direction such that its tail coincides with the head of first. Then this was A, this is B from this very point up to this, then this very is vector R. And what is vector R here? Resultant. It is A minus B. A vector. And always the resultant lies in the direction of bigger vector. Which is bigger among the two? It is vector A. So the resultant will be in this very direction. If it could have been like this with situation is this is vector A. This is vector B. Now what I am supposed to do, how I'm going to add them up like this. This is the vector A. पहले मैंने वेक्टर A को लिखा, फिर वेक्टर B को ऐसे डिस्प्लेस किया कि इसका टेल पहले के हेड से कोइंसाइड हो जाए, ऐसे 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 like this. So this was B, and now from this to this it is R equals to A minus B. And again now the direction is again the bigger vector, because here now the bigger vector is vector B. Direction is always direction of resultant vector. What is the resultant vector? A vector which produces the same vector as it produces by two individual vectors or three individual vectors. Direction of resultant vector is always in the direction of bigger vector. Hope you understand what I made possible for you people. This is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.